Hello, fourth graders. Mr. A is with you, and I'm happy that you are taking care of your responsibilities, that you are working on your homework, and we are reviewing equivalent fractions. And page one of our new homework is asking us to find equivalent three fractions that are equivalent to 2/5. Okay, so I'm going to make up a fraction. Let's say we have 3/7. Okay. I want to find three equivalent fractions to 3/7. Okay. So we have two problems on our homework. One is just to find, three equivalent fractions, and the other one is, um, there is a number line, and we want to place fractions on a number line. So I'm gonna do the equivalent fractions in two ways. I'm going to do it first by using a number line. So whenever we have a fraction, we have to remember that all fractions belong to a whole. Okay, they belong to a whole. So that whole was once in one piece, but it became a fraction after it has been partitioned and broken into parts. How many parts is our whole made of? It's made of seven because our denominator is seven. So that tells us that our whole is made of seven parts. Okay, so I'm gonna uh, think about the number seven. The number seven is an odd number, so I'm gonna make a box in the middle for my odd number. Seven is made of six plus one, so I'm gonna make three on one side. So one, two, three, four, five, six, seven. So I made seven parts. Seven parts make up a whole. So if we have all the pieces of the seven, that would be 7/7, which is a whole. If we have none of our sevens, that would be 0/7 or zero. Now, our numerator tells us that we have three parts. We have three parts out of the seven. So here is 1/7, 2/7, 3/7. Okay, so here we have our 3/7. So that is, almost half, but definitely less than a whole. Okay, so it's less than a half because half is going to be about here. Half of 7 is 3.5 or 3.5. So 3 is less than a half. Okay. So now, how do we find equivalent fractions? It's very simple because equivalent fractions mean you have the same amount, but you're partitioning it differently. So the easiest equivalent fraction that I can come up with is breaking each seventh into two parts. So that means taking each seventh and breaking it in half. So basically, I'm taking 3/7 and I'm timing the 7 and the 3 by 2. So the first equivalent fraction that I can get is 6, and 7 times 2 is 14 because 3 times 2 is 6 and 7 times 2 is 14. Okay? Now, I can create another equivalent fractions the same way. If I take my whole again, that is broken into seven parts. Okay, one, two, three, four, five, six, seven. Seven sevens make up a whole, and we have only 3/7. I can partition the 3/7 into three parts. Like the first time I did by two, the second fraction, I'm going to partition it by thirds. So I'm going to break each seventh into three parts. But I have to remember that my original fraction was only 3/7. Okay, so now if I break 3/7 into three parts each, how much that's going to be out of a whole? So, okay, I had 7 originally, so if I times 7 by 3, that gives me 21 pieces. And the available parts, I had 3 originally, 3/7, but I broke each 7 into 3 parts. 3 times 3 is 9. So my second equivalent fraction is 9 21st, right? So 9 pieces out of 21 parts, right? My third equivalent fraction, again, I can use a number line and break it into 7 parts. 1, 2, 3, 4, 5, 6, 7. And remember that I have 3/7. If I take each seventh and break it into 4 parts, so I just have to draw 3 lines to make up 4 parts. Again, I took each 7 and broke it into 4, but I had only 3 out of the 7 available. So I uh, multiply the 3 by 4 as well. So that gives me 12 pieces of 28ths. Okay, 12 pieces of 28ths. And I have my 3 equivalent fractions. My 3 equivalent fractions are 6/14ths, 9/21sts, and 12/28ths. These are my equivalent fractions. And I did it by partitioning each sevenths into the same amount, either halves or thirds or fourths. So I have to, the shortcut is if you want to find an equivalent fraction to 3/7, you have to multiply the 3 and the 7 by the same factor, by the same number. And that's how you can create infinite, as many equivalent fractions as you want. But just remember, they have to be multiplied by the same factor. Okay, so I hope this lesson is helpful. I'm looking at number 2. Don't don't get intimidated by number 2. It is the same concept. You have some fractions that are made of tenths, right? Like 1/10. You want to place let's say a fraction that is um let's say 25 hundredths, okay? And you have 1/10, you have 2/10, okay, on a number line, and 3/10, okay? So this is our number line, okay? Now these numbers are in tenths, but we can find the equivalent fraction by breaking and partitioning each tenth 10 times. So we find the equivalent of 1/10 is the same as 10 hundredths, and the equivalent fraction of 2/10 is 20 hundredths, and the equivalent fraction of 3/10 is 30 hundredths. So now, where would you plot 25 hundredths? Can we plot between 10 hundredth and 20 hundredth? No, because 25 hundredth is bigger. So 25 hundredth is going to sit well between 2/10 or 20 hundredth and 3/10 or 30 hundredth. Okay, so I hope that hint is helpful, and I look forward to see you growing and learning and being successful in my class. You just have to do the work and show me your reasoning, please. Thank you very much.